Hey there folks, welcome back to another part of my thing where I am making a Tetris Game Analyzer. That's the one. So last time I was involved in trying to figure out when we were playing and when we were not by testing a certain portion of the screen, and it was a very long and boring video filled with a bunch of inaction and silence and crickets chirping as I tried to figure out a unique part of the screen on the playing screen, which would uniquely identify that the game is playing or the game has stopped playing. So, and while I was doing that, I committed a very cardinal sin that naive computer programmers wouldn't really catch, but it's something very bad, and that's relying on null to provide information. And I'll explain why that's not the greatest thing in the world. We won't go too much into it, but when I was in high school and I was doing all of my childhood programming, we didn't have, it wasn't object oriented. Everything was value-based. I'm trying to think if there was any kind of... I think you could do reference variables, but you had to do it in a certain way. And I never really used anything else but void methods and passed in primitive values. So I never got any bad habits with the null keyword. Null comes in to languages which you declare variables on the heap instead of the stack. If you don't know what that is, forget about it, doesn't matter. But the problem with null is it's a state, it's not a value. And if you have written code that relies on null providing information, you've got a problem, because anytime you try and dereference something that's null, it throws an exception. And null should really be treated as, hey, I don't have a value. Don't ask me about any decisions you have to make. Don't even make a decision because I'm null. And if you recall, we were trying to get the value of a digit. And let's just see here. What did we do here? Yeah, so here we get the value a digit. So let's go into get digit. We reduce the image, and in reduce image, we actually decided to return null if we couldn't find a non-black row. And that's really unfortunate. One of the things we could do is to introduce an option keyword here using a NuGet package that takes care of a functional style programming. I wonder if there's anything in here . Anything in image. I don't want to get into functional programming at the moment. Okay, I think what we're going to do, rather than return a null here, let's just return a new bitmap. Now, can I not? Whoops. 0, 0. Okay, so this is where it first starts. We made this a nullable integer, which means it's an integer which can have a null value. Normally integers can't have null values because they're value types. They're declared on the stack. And so what we need to do, because I don't want to rely on nulls, that was a bad decision. There's a standard in computer science that goes back decades, and that's if a method is going to return an integer, but you want to declare that there was something went wrong and an error happened, what you do is you return -1 if -1 doesn't make sense for your context. So in this case, we're only going to care about positive values because we're looking for the number of the row that's not all black. So if we don't find anything, we're going to return not a null, but we're going to return a -1. Okay, so, and similarly, we're going to do this for the columns as well. This is a little more proper. Okay, and then we're going to find the first non-black row, and then we can say something like this. If top is less than 0, return a new bitmap that's just default. Default bitmap. Here we don't have to look at value anymore because it's not a nullable integer. That does make that a little better. This makes this a little better. Okay. Okay, perfect. And I think yeah, that will work. So that's better. I like that. So let's go to where we use reduce image. Reduced image, we now will know we know it will never be null. But we are going to check to see if it's, you know, height. Actually, this could be a good case for an extension method. Let's have a look at where we are. We're in the digit reader. This is the digit recognition in the Tetris data extractor. Let's make a new method called extensions. And we'll make a new class called bitmap extensions. Extension methods are something in C# that are awesome. You can do too much with them, but oh, whoops. You can go crazy, and it's not good to go crazy with them, but this will actually add extensions to a class you don't own. I'll show you what I mean. So we go public, and it's got to be a static class. Public static Boolean has data. We're going to say has data. This bitmap. And this keyword makes it, specifies that this is an extension method. What's wrong here? Could not be found. There we go. What's wrong here? A non-generic static class. It is. You don't know what you're talking about. Okay. We're going to say return bitmap.height is greater than 0. Actually, let's call this isEmpty. I like that, and then return the fact that it is equal to 0. Okay, that's fine. I don't think that has an issue. What's happening here? Generate overrides. I think the IntelliSense is getting a bit confused there. Okay, so now we can go to digit reader. And now I can say if reduced image dot is empty. And we can using Tetris data extensions. What's wrong? Yeah, see, it really doesn't like this. I'm not sure. Public static class bitmap extensions. What? Something is really weird, wonky with my IntelliSense. See, I built it and everything was fine. So I'm not sure what the issue is here. Stupid Visual Studio Code. Duh. This is so frustrating. If I get out of here and then open it up again, this is not what I need. This is so not what I need. Ay, ay, ay. No definition. Whatever, I don't even care. So something was wrong with IntelliSense. So now I can say this nice is empty. If the image is empty, return string.empty. Okay, that's good. Okay, now where do I use getDigit? I use getDigit here. Now if we're going to say if string dot is null or empty, and digit then is valid as false, otherwise set it there. And if it's not valid, we're going to return a -1. That will complain because of this. Okay, that's good. Good. Now in my Tetris data model, let's get my Tetris data model here. Get value at will actually return a -1 if something happened and something was wrong. Or no, currently it will return a -1 if it was empty. So is playing, let me see here. Var play check equals screenreader.getValue. Now if play check is, we're checking to see if we're playing. If play check is less than 0, then is playing equals false. Okay, That's not the only thing, because we need the rocket screen. That was going to be fully bright. And then we also need the music select screen where it was pretty much mostly filled in. So, but we do know that if it was empty, we're definitely not playing. Now we need to check for if it's a digit or it's fully not black. And that's interesting. How are we going to do that? This check is going to be made every time. So I want it to be quick. Actually, let's rename this. I don't think... what do I do? F2. Yeah. Else if top equals 888, then is playing equals false. So we can say or top equals 888, otherwise is playing as true. Oops. I could totally spell true. Okay, now I can go ahead and simplify this. I can say is playing equals top is less than 0 or top equals 888. We can negate that. Oops. And let's make it greater or equal to and not equal to 888. Then I can get rid of the negation. So that is my logic for if something is playing. Look at the top. If it's greater than 0 but not equal to 6/8, then I'm good. I think that score is extremely hard to get. The only issue I have is when you get a Tetris, at least part of the screen flashes. And so if it flashed right at that specific point where we took our screenshot, it might actually say 888. Now what I'm going to do is I'm going to put in, I'm going to throw an let me think here. No, I don't want to throw an exception. Because the thing is, I will never get 888. I'm just not that good. I mean, it'd be fun if I was, but I'm not. So I was thinking of throwing an exception, but I can't throw an exception because the rocket ship screen will say 888. Okay, we'll just leave it like that. We'll hope that everything is good. All right. Okay, so that's how we check to see if something is playing. Let's go up to our game analyzer now. We will take a screenshot, and actually, I don't think we need to catch an exception. But let's actually write because I think we figured out our transient errors last time, which I was just catching and nullifying here with this empty catch block, but I think we figured it out. So I don't expect any weird exceptions to be thrown. But let's just do this. Let's send the message and the details of the error to the screen. Whoops. Curly brackets. We're almost there. We're almost getting this. Boy, IntelliSense is super... Oh, what? Dot message. Oh, I thought there was a details. I guess there's not. Good, okay. So that's fine. If change detected, update the data model. Here we're going to change it. We're going to take the screenshot, and then we're going to say if screenshot dot is playing, no, whoops, no, I need to make a data model first. If data model dot is playing, if we're not playing, continue. Now what the continue will do is it will break out of this and go back up. So execution will stop here and it'll go back up to here and it'll just keep doing this. Actually, I think we should maybe have our delay. Maybe I should do this. Instead of continue, I want to delay as well, even if you're not playing. So let's do this. So if you're playing, then do this. But if you're not playing, it's just gonna skip over, delay it, and like that. Now, what I need is var last screen. We'll just call it last time. This is Tetris data model. We're going to set that equal to null. Whoops. Because what I want to do is I want to know what happened last time and what happened this time so I can start a game, right? So we'll create the data model factory. Actually, let's just do this. No. Bar is playing equals false. Okay, get the data model factory. if is playing equal, so we're going to do this. If not is playing and data model dot is playing. So in this case, we weren't currently playing according to the analyzer, but the new screenshot says we are playing. Then current game equals new game model. Okay. Else, if we have been playing and data model is playing, sorry, not is playing. This is the other way. So if the analyzer thinks we're playing, but the new screenshot says we're not playing, that means the game has ended. So console.writeLine game ended, final score I'd really like a Tetris data model last time. Get the screenshot, get the data model. Here we're going to say, oh, come on. Ew. Take the screenshot. What I'm going to do is just before I wait, I'm going to say last time equals data model. So that I can get access to the last score last time. Now the first time we go through this loop, last time is going to be null. It's just it doesn't have data yet, and that's okay. Because the only way we're going to get there is if we thought we were playing. But the latest screenshot says we're not playing. I think that's safe. So we've stopped playing. And then is playing equals false. Okay. I think that's all right, folks. What do you see? Should maybe put my arms down. I think that's good. We're going to take a screenshot. We're going to look at it. Check to see if the state of play has changed. If we started to play, we're going to make the game model be brand new. That will get a zeroed out score and all that stuff. If we've stopped playing, we're going to print out game ended and our final score. Now, if we're playing, and remember, this is okay to look at this. To look at this property inside the data model because it's lazily loaded. Right? If it has a value, we just return it. We only do that once. Then we do all this stuff. Then we set the current data model to last time. Let's call this last data model. Then we wait for a second. Then we go ahead and take another screenshot. If anything happens, we're going to print out the error message. Let's print out new game starting. New game starting. Awesome. Okay, let's build this. Oh, this is going to be good. If this works, I'll be very happy. Okay, we're done. We're done. We built it all. Let's do this thing where we run it. We have to open up VLC. I have to turn my Nintendo on. Oh, my Nintendo's already on. No. There we go. Bring this over here. Turn my volume down. Let's run this. Run without debugging. All right. It's building it. Here we go. Here we go. What? One or more errors occurred. Parameter must be positive and less than height. Holy crow. Okay. Stop. What's happening? Rectangle. Zero. What? Cannot have a width or height equal to 0. Parameter must be positive. Oh boy. Oh boy. Hug. What is going on here? So I'm thinking that in the digit reader, when we read, the image reducer, shoot. I'll bet, yeah, this is it. I'll bet the bitmap has a getter and a setter. And if you try and pass in 0, it's gonna start crying. Ah. Do I really? Shoot, I am going to have to check for null here. So bitmap has this thing, and we can even verify this by going C# bitmap class. Look at this thing. Well, plus they seal it. That means I can't even make a child class of it. Constructors. I think somewhere there's going to be a, you can't set this equal to 0. Okay, that's too bad. And that's what the option class is for, and functional style programming. Unfortunately, we don't have any functional style programming in this game analyzer right now, which is something that we may introduce in the future. So what I'm going to do instead is we're going to make an out parameter, out boolean is empty. We're going to add this to here, out boolean is empty. Because I really don't want to check for null. So we're going to say is empty. Actually, we'll do it right here. Is empty equals top is less than 0. Then we'll return null. Okay, when we look at this in here, we'll say out bar is empty. So is empty is a variable we're also getting back. It's kind of a way, out variables are a way to pass back information in addition to your return parameter, your return value. Yeah, we don't need this anymore. We can just say is empty. If it's empty, return an empty string, which means there's no point in having bitmap extensions. And we don't have anything left in here. So, okay, that was kind of, I was hopeful, but it's not the end of the world. We're also going to have an issue when we reduce the canonical image, but the canonical image is always not empty. So what we can do is we can just say out and underscore saying we don't really care about that value. Let's build this, see what happens. Oh, of course, because we're looking for the extension method that doesn't exist anymore. Let's try and build it again. I'm just going to say I hate Visual Studio Code for .NET programming. It's awful. As good as the potential is, as good as everyone seems to want to say, it's just, you know, Visual Studio's up here. VS Code is way down there. So, okay. Good. We can bring this over here now. Let's make sure. Run without debugging. Turn on this television. So the first time it boots up, it's going to say, oh, there's nothing. I looked at the top. What? Really? Oh, this is weird. Okay, I'm going to have to debug this. Start debugging, please. Whoops. What is its problem? Okay. Take the screenshot, get the data model. Let's go into is playing. Exception out of range. What is the current row right now? 22. Because we add it. That's why. Here I thought this would be great, but we're actually adding step to current row. And then looking at the pixel. So we have to actually say minus step. Current row, it would be, because there's only 21 pixels. So oh, for crying out loud. Wait a second. No, it is the width. Oh, shoot, no. No, it's not. We're finding the first non-black row. Current row is height. Then we're looking from 0 to the width of getting that current row. So when we look at row, we're going from 0 to the height. So the height is only 21 pixels. That'll be row 0 to 20. So current row, if it's 20, if it's 19, then it'll be 20. 19 is safe. If it's greater than or equal to the height minus step, height is 21, step is 1. So even if it's equal to 20, it's going to cut out. 19 is safe because 19 to 20, 0 to 20, 1, yeah, that's okay. So here, columns are going to the width. Minus step. That's okay. Maybe I can set a 0,0 size in a bitmap. Oh well. We've already done it. Interesting. I think that's right. So let's try this again. I'm going to run without debugging because debugging really slows things down. What are we at? 44 minutes? Oh man, look at my scores. 8, level A9. No, parameter must be positive and less than height. Shoot. Okay, let's start debugging. I still didn't fix it. I think I see the issue. Oh, it's fascinatingly frustrating here. So here's the issue. It's because I got this check wrong. This is a while loop. This shouldn't be an or. Both of these things should be true in order to keep going. So this should be an and. And this is the wrong way. You don't want to do this while. So in this case, found is never found, right? And so found is always going to be false. And so this is always going to happen because it's one side of an or statement. Excuse me. Oh boy. Okay. So keep doing this, not an or, it's an and, while it's not found and your current row is less than this. Keep doing this while it's not found and your current column is less than that. Okay. This is taking way longer than I thought it would, but we might be there. And my Nintendo's all screwed up. See if that fixes it. Okay, run without debugging. Let's go. Let's do this. Good. Hey, look at that. It's not dying. Let's start a level 9 game. New game starting. Oh, now it's always Whoops. Uh-oh. There we go. Oh, it's always saying new game starting. Why is it always saying new game starting? Oh, now it's not. Yeah, it is saying, what? Why is it always saying new game starting? There. That's annoying. It says new game starting. Oh, because I never set it to true. Look at that. I never set is playing to true. Is playing is always false. It's false here. I change it back to false when I'm not playing. I need to say is playing equals true. There we go. I'm just going to run it now. Run without debugging. This should automatically build it. Okay. Awesome. So we're going to new game starting because it sees the top. Nothing's changing. I'm going to hit start. And it should say game ended. Final score is 3442. New game starting. Okay, let's see what happens. Perfect. I'm not getting any, new game. Of course, I'm not getting any Tetrises either. My Tetris rate is still at 0. Awesome, there's a Tetris. Tetris rate should now reflect that. Okay. Let's say something happened to me. And I topped out. Boom, I topped out. Oh, too bad. 26,732. Game ended. Final score, 26,732. And it's always checking. Now, I want to see if the rocket ship screen. Yeah, let's get the rocket ship screen. See if it knows the rocket ships. Oh, new game starting. This is awesome. So I want to get more than 32,000, which should be laughably simple. Huh, but you never know. Sometimes I really suck. Let's do yuck. Dudes, come on. What was that? Oh my goodness, am I going to get 32,000 points when I actually really wanted to? I mean, yeah, I will. It's really hard to, on purpose, or by accident, get 32,000 points. But hey, look it, I'm doing a pretty good job of stinking right now. Oh my word. Oh, for crying out. Okay, that's embarrassing. I didn't get a single Tetris. There's my game ended, final score. I want the rocket ship screen, please. Just give me the rocket ship screen. Here we go. This will, I mean, 2 Tetrises gets you the rocket ship screen on level 15. Oh, that's not 4 high. Oh, yeah. Oh my goodness. Good thing no one watches these videos. Now I'm getting droughted. That's fun. Oh, where's my long bar? This is what we call a drought? Pretty bad one. I want to put a drought counter on my game analyzer. Okay, finally. Okay, 32% Tetris rate. Now, it should say stop playing when we get to that screen. Game ended. Final score, 50,787. Awesome. Now I'm going to reset my Nintendo. Interesting. So there's a problem with the title screen still. And this says a new game is starting, which is unfortunate. Okay, so the title screen and the music select screen has issues. Now game ended, final score is -1. Well, that's exciting. I gotta write that down. Or maybe just look at this video. But I think we're gonna stop it there. I mean, we've accomplished, well, we finally accomplished what I wanted to do last time. But so the title screen thinks it's playing. That's interesting. We got to figure that one out. And the game select screen, no, the music select screen. Wait a minute. What was the issue? I don't even know. I can't remember. Okay, the title screen thinks it's playing. Yeah, our title screen thinks it's playing. So the game select screen says new game starting. So actually the title screen is showing an error. The music select screen thinks it's playing. Yeah, the title screen didn't necessarily think it's playing. It just has this rectangle 0, 20, width 0, height 1. Very curious. I'm not sure what that is. But we'll have to dig into that next time. But hey, we did the is playing. Now we can play in a loop. So that's great. And this actually won't hurt anything for our current game, because we can just go to 19 and it says now we're starting a new game. It's like, what? That's awesome. Level 19 is so fast. Oh yeah, I tried to rotate an O piece. And now the other thing we have to do is start. Once I hit start, it'll think game ended. And then it'll say game's playing. So we could probably figure that out by saying, if this is a new game is being detected, but you already have a score, you must have paused it. But we have to do something with pause. Anyway, that's it for now. That's enough. That's enough. I've had enough. Thanks for joining me. Have a nice day, and we'll see you next time.